Time for another exciting educational slideshow. It's possibly hurting your eyes with that zoom level. I can zoom out just a little. Is that any better, or is that actually worse? The text looks kind of funky on my screen. At the top, Lambda Orionis, which I think is right, sir. Right ascension 5 hours 35 minutes and 6 seconds, declination plus 9 degrees 56.0 minutes. Bellatrix, RA is right ascension, 5 hours 25 minutes 8 seconds, declination plus 6 degrees 20 minutes and 59 seconds. These are all search results that come up in different ways because I get them from different sites. Because of course there is no single catalogue of these. Yes there is, there are dozens, but I didn't open one and read through it. I just looked up a few named stars. You can see quite a lot of these. I probably should have introduced extra spaces to make it line up better. Below Capella we have Epsilon Aurigae, Iota Aurigae, Zeta or Zeta Aurigae. Aurigae? Aurigae. Auriga. Auriga. I don't know. Don't care. I don't know what that constellation's supposed to be. The pregnant panda or something. Lots of Greek letters. Name of the constellation. Capella would be Alpha Aurigae, the brightest one. Beta, the second brightest. Gamma, for some reason, doesn't seem to exist. Delta Aurigae. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, etc. Aurigae. There are a lot of stars in it, but I only went with those. For each of these, we have right ascension, which is how far east from a particular point, a particular meridian through the sky, if you like, the star is, and declination, which is how far north of the equator it is. Notice all the ones in Auriga are positive. They're all in the 30 to 55 degree range. But the Orion stars, Bellatrix and Betelgeuse being the shoulders, Rhisa at the top of the head, Mintaka and Anilam being the belt, and Regal and Safe being his feet or knees, depending how he's drawn, they go from plus nearly 10 degrees north, down to minus nearly 10 degrees south of the equator. And then I have Sirius, which is 16 degrees, 16 and 2/3 plus a bit, nearly 16 and 3/4 degrees south. Those are great for astronomers to convert those into angles. You would multiply the seconds by 3,600 and the minutes by 60 and add them to the hours, and then multiply by 15, or multiply seconds by 3,600, multiply minutes by 60 and add to the degrees to get you your longitude and latitude of the ground position of the star at some arbitrary time. The way the zero right ascension is defined would actually tell you that time. You can look it up if you really care. Ignore the Ghana location for now. Also don't ignore observer location for now. I'll tell you about the observer location soon. Underneath that we have longitude and latitude, the conversion I just described. Taking Lambda Orion, let's take Bellatrix, pretty blue star, top right of Orion. 5 hours 25 minutes and 8 seconds multiplied by 15 degrees per hour, a 15 degree per hour drift, thanks Bob, is 83.775 degrees. And 6 degrees 20 minutes and 20 arc minutes and 59 arc seconds is, I think my line just slipped, yes, I'm now looking, yeah, Bellatrix. Sorry. I did that on purpose and then forgot I'd done it. 6.34972 degrees north. If we look at Mintaka, that's the ludicrously hot blue star at the leading end of Orion's belt. That is 5 hours 32 minutes and no seconds, which is 83 degrees. And it's 0 degrees 17 minutes and 57 seconds, arc seconds, south, negative declination, which puts it at Oh, that's good. I screwed up, and I've only just noticed. 0.29917 degrees, but that should be a negative number. So this whole thing is going to be wrong, because I missed out the negative, but it's not going to be wrong by much. We have an 83 degrees there. That is barely above the horizon to the east. If you wait approximately 5 hours and 32 minutes, Mintaka will be above longitude 0 instead of longitude 83. If you redesignate longitudes based on a meridian through this observer location rather than through Greenwich, this observer's location becomes longitude 0. That is the next table down, the bottom table. All longitudes change to be relative to a meridian through that observer position when Mintaka is directly above that meridian. So you get some stuff to the left, which is a positive number, and some stuff to the right, which is a negative number. And your latitudes stay the same. That actual observer location is shown here twice. On the left, we have much zoomed in. It is this point in the middle of the red circle, surprisingly, at Brimham Rocks. And on the right, it is this point marked with the this point marker, which has been plonked onto Brimham Rocks. The correct part of Brimham Rocks, even. I'm good like that. We have another location, also marked, zoomed in on the left. It's that spot in the centre of the circle, not quite the southernmost bit of that patch of rocks, just sort of the southeast part of that northwest to southeast slope, west of the southernmost part of that rock. Which is at the same, it's on the same meridian, it is the same distance west of the Greenwich meridian. It is shown on the right, more zoomed out, on the coast of Ghana, which is as far south as you can get on that meridian and still be on land. Having got latitude and longitude, you can convert them to coordinates on an azimuthal equidistant projection map of the Earth centered on the North Pole, with the meridian straight ahead. If it's sitting on a table, the meridian of our observer is pointing away from you, with x coordinate being to the right and y coordinate being how far beyond the center it is, how far beyond the North Pole. It's quite simple. You subtract the latitude from 90 degrees, and that gives you the distance from the centre, and you multiply that distance by the sine of the longitude to get how far left of centre it is, and by the cosine of longitude to get how far beyond centre it is. That gives us our x and y. For y rel obs, y coordinate relative to the observer at Brimham Rocks, you just subtract the y coordinate of Brimham Rocks, which gives Brimham Rocks itself a y coordinate of 0, and relative to Ghana, you subtract the y coordinate of Ghana, which is of course 90 minus the latitude of that point on Ghana. That gives us these coordinates of the ground positions of those stars on an AE projection centred on the North Pole. According to Brian, nautical miles, minutes of arc, or sky miles, meaning apparently he thinks that not only is sea level flat, but the sky is too, and all the stars are at the same level up there. If they're at different altitudes, it gets even worse, believe me. And you also have that flat sky channel. Question would be how high up, but the easy way to answer that for these people who can't do complicated trigonometry, like, what's the sine of 60 degrees? Anyone? Would be to take 45 degrees. If you are at 45 degrees latitude, then, and you're on the correct meridian for the sun to cross your meridian at the moment of equinox, then at that moment, at local solar noon, at the moment of equinox, the sun directly over the equator, and the north or south celestial pole, depending which side of the equator you are, will be at an elevation of 45 degrees. That's great, because if you extend 45 degrees up from this flat AE map that you're assuming is an accurate three-dimensional model of the Earth, for some bizarre reason, the distance up from the equator or the pole or the rim, South Pole, rim of the map, same thing, it's actually just one point. It's just all the way around the outside because that's a projection, but never mind. To where that line intersects is the same as the distance along the map from there to the base of the line. 45, 45, 90 triangle. Really simple. In which case, I can put in a very simple height. It's 45 because these are in degrees. Each of these are in units of 60 nautical miles or 690 statute miles or 111 and a bit kilometers. Degrees. As we're talking perspective and angles, it all works the same whatever units you use. So, I can take all of these coordinates and put them into my Cartesian coordinate thing and get X and Y coordinates in a photograph. You'll notice in each of these, I have, well, at the top I have from the North Pole, in the middle I have from River Rocks, at the bottom I have from Ghana. In each of these, Mintaka is at 0, 0, because I put in the coordinates for Mintaka first, and then I used the elevation angle calculated for Mintaka as the elevation angle of the camera. So in each of these, Mintaka is the center of the field of view. You're looking at that one, and Orion's belt is to the left, and Orion's shoulders are up, and Orion's feet or knees or whatever are down. And Mintaka, dead center of the field of view. Sirius way off to the bottom left. And we get this, which has gone wrong. I'm sure it's gone wrong. I'm bound to have got it wrong. Up at the top we have this loop. Right. We have two of it there, and one of it there in red. And now down here we have the familiar shape of down here we have the familiar shape of Orion. Sort of. Kinda. Maybe. I think it's gone horribly wrong. The white one is Mintaka. The red is all drawn from the North Pole. The green is drawn from River Rocks. And the blue is drawn from the south coast of Ghana. And I've cut the bottom right off him, cropping it. Over here on the left, I'm not sure what I did wrong with blue there. I'm pretty sure this one that's sticking out to the left is actually Sirius, and I don't know where the heck Betelgeuse and Risa have gone. This red one here is definitely red Sirius, and oh no, it isn't. That is Betelgeuse. This is red Sirius. Down here on the left is green Sirius, and blue, as in drawn from the North Pole Sirius, is off the left side of the image. I remember now. Yeah. So that is Betelgeuse put in a very strange place. The upper part of Orion has been bizarrely squashed when projected from the North Pole, and I don't know why. But you can also see that when projected from Ghana, blue is from Ghana, red is from the North Pole. You can see how he's squashed vertically when seen from the North Pole, and gets taller when seen from River Rocks, and then a whole lot bigger when seen from the equator. Well, near the equator. Ghana isn't on the equator. Above we have Auriga as seen from the North Pole. You can see how this very tall point up here at the top. And a slight extension to the right. By the time you get to Brimham, it's a whole lot wider. The top is still stretched out, but look at the shape of it. That straight line down the right and that angle becomes that shape. And then seen from Ghana, you get the blue shape where it's kinked back down again, and you get much bigger extension to the right. The southernmost, nearest part of it appears much wider than the northernmost, farthest part of it. Why? Perspective. Actual perspective, not Karyo Abenga's made-up nonsense. Also, you can see that in the red projection from the North Pole, it's not just Orion that's flattened. Auriga up here is pushed down, sort of, squished down towards Orion. because the gap between them and the length of it are flattened too. The whole thing is being viewed at an angle that is a lot farther from perpendicular than it is when you're actually underneath Auriga and looking pretty much straight up at it, just when it's green, or when you're underneath Orion and looking up when it's blue, which has, as you can see, gone wrong. Why is it bigger? Again, perspective. Stellarium. This would be from the northern end of Greenland, because it won't give you from the North Pole, and the time adjusted to get Mintakar due south. Unfortunately, the bottom part of Orion is now below the horizon from this far north, because of course it's below the equator, south of the equator, below as seen from an extreme northern latitude. And we can have the view from Low Lathe, from pretty much Brimham Rocks, again centred on Orion, with, you can see Capella is labelled, and that's sort of one southeast of it, and then a pair, and then one down to the southeast, and one at the bottom, and two on the left. That's the same constellation. I have no idea what they thought that looked like. It's just a bunch of stars. They're not even close together, really. They're just in similar directions. And from Ghana, looking up. Might not be from Ghana. It is from Ghana. From pretty much that rock, looking up. You have Orion in the centre, you have Capella at the top, you have other stuff around. Very similar looking views. If I take Greenland and I think Wales and Spain and somewhere that wasn't quite Ghana, and Cape Town and Cape Hope in South America, and get views centred on the middle of Orion's belt and lay them together, I get this. All different angles. But you may notice this, it's kind of looking like star trails. They're kind of in circular rings around that central point. What happens if I rotate them all to line them up? If I rotate them all to get the line from Betelgeuse, top left, to Regal, bottom right, at exactly 60 degrees in every single frame, all labels get spun all over the place, and because I wasn't quite pointing right, the ones out at the side, like Capella, get kind of messed up. But Orion looks, because it's at the centre of the view, looks just the same no matter where you are when you look at it. And Sirius is the same angle away from it. It doesn't get pushed off the left side of your field of view just because you're in Ghana. So either Stellarium software, which loads of people have used to predict views and to line up telescopes and to say what they can see where, and which appears to work perfectly, is completely wrong, and this view does change, but somehow nobody has ever noticed and posted online to say, hey, I took a photograph of Orion and it doesn't look like the diagrams, because Orion from my country looks very different from how it looks in the country where this astronomy magazine is published, or anything like that. Nobody's ever pointed out that the constellations change as you move over the surface of the Earth. Or Stellarium is correct and is doing this properly, and the constellations do look the same wherever you are on the Earth's surface. And Brian and Flat Sky and their planar sea level and planar sky 2,700 nautical miles up are incorrect.